The views expressed on Skeptically Speaking are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Bring it on! The skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. 'Cause we're skeptically speaking.
Hello and welcome to Skeptically Speaking. I'm your host, Desiree Shell. I've often mentioned over the course of the program the love I have for science communication, particularly creative science communication. Carl Sagan was able to capture the wonder and awe of science with his words. Others have used art to explain scientific theory in a way that words couldn't. Some people have been inspired by the natural world or by technology and created pieces that reflected that. And sometimes we explain art using science, and suddenly the piece is breathtaking in ways that we hadn't even realized. We here at Skeptically Speaking think that science is beautiful. And today's show will touch on a few ways that art can communicate science, and that science can tell you more about art. Our guest is cognitive psychologist, neuroscientist, record producer, musician, and writer, Daniel Levitin. He's the author of This Is Your Brain on Music. But let's start off with some speaking up. I'm speaking today with Raven Hanna and Logan Daniel about their new project, The Science Tarot. Welcome, guys.
It's so great to be here.
So the words science and tarot, they're not traditionally used together. And in fact, I would almost consider them fairly far apart on the evidence-based continuum. Would that be correct? Raven?
A lot of people see science tarot and they say, oh my gosh, what an oxymoron. And it is at first glance, and I probably would think the same thing. But the way that we have put these things together, it actually does make sense. What we've done is we've taken the ideas of tarot cards and reinterpret them with stories from science. So there's a lot of real science in here, as well as keeping the traditional tarot symbolism.
Well, Logan, tell us about the cards.
The major arcana are the cards that we attacked first because they are each an individual concept or story behind each card. And so it was very exciting and also a little simple to put a science story with each card individually. When we tackled the minor arcana, which are 4 separate suits, we had to come up with 4 separate stories over the course of 10 cards. And those were related to Joseph Campbell's hero's journey as a sort of a way of telling mythology stories. And then related our science concepts on top of that to show the 10 steps of a journey through each of the suits.
Could you tell us one of the stories?
Actually, why don't I tell you the overarching story through the 4 suits? It gives you a better context of what's going on. The Wands suit is about creation, and it's where we begin. So we gave that to stars and astronomy because they're the creators of the most basic elements of the universe and a great metaphor for anyone who creates projects, artists, that sort of thing. And we picked different examples from the life cycle of a star to exemplify what that life story is of an artist. From Wands, you go to Pentacles, which is about particle interaction. And there we get into concepts like geology and chemistry and the interaction of all these elements that were created by the stars and the mixing up of things. From there you go into Swords, which is the suit of thought and of directed action. So for that one, we looked at reductionism. And now that everything's been interacting as it was in Pentacles, you start becoming aware that there's these other things in the universe, and you start observing them, and you start bringing into the lab and dissecting them, and you get curious about them, you start picking them apart. Swords is the only suit that doesn't have a happy ending. If you live by the sword, you die by the sword. And so for the end of the sword suit, we ended with the Heisenberg uncertainty principle, because you find you can't actually reduce the universe completely. You can't always know where everything is at any moment. And so you step back onto the path of cups now, where again you use a scientific method, but you look at the universe with you in it, and you step back and you look at larger systems and ecosystems and emergence and a holistic process of the universe. And the suit does have a happy ending, and you become one again with everything in the universe, just like you did at the beginning with the wand suit.
So each face card is a scientific portrait.
Yes. So traditionally, tarot cards have 4 face cards. They have page, knight, king, and queen. And we actually abstracted this into different properties that a scientist might have. So, for example, the page is now the explorer, the person who might be a novice, but is very inspired to observe the world just because of raw enthusiasm. And we have chosen a historical scientist, and more specifically, like a part of that scientist's life, to be an example for these different stages of science and people in it.
And you've used Carl Sagan.
We have. Carl Sagan is the storyteller of the suit wands, and I love how he is depicted on the cards. He's shown trying to give you a star. Carl Sagan is certainly one of the most influential voices that has inspired a whole generation of people to become scientists, as well as people who may not have been inherently interested in science, but through his enthusiasm, he brought it to them.
So how do these relate to conventional tarot cards? Does the Two of Swords mean the same thing in your cards as it would in a traditional set?
Yes, we were very careful to make sure that the concepts that we chose for each card, so the Two of Swords is actually Newtonian forces, and so it's about balance and making a decision. We wanted people who are familiar with regular tarot to be able to pick up this set of cards and be able to use it. Because, of course, one of our main audiences are people who know about tarot but may not know so much about science, and we hope that through this work they're able to learn more about science and begin to appreciate it.
So are you actually giving people the opportunity to sneak science into their hippie friends' houses? Because I support that.
Maybe. Definitely. In fact, we've already had many people, scientists, say, "Oh, I have the perfect woo-woo friend that needs one of these."
Now, there are 3 co-creators of this project, so what are your backgrounds?
Well, I come from a love of science, not a professional background of science. I studied physics and biology extensively through university and then graduated as a music major, which is what my career was for the first 10 years. I did audio design for kids' educational games, and so even then I was still involved in a love of nature and a science communication outreach. And after that, I did landscape architecture as well as some science communication art installations. So it was still happening in that format as well, which is how I ended up doing Science Tarot with Raven and Martin Azevedo, who are often people I create projects with over the years. And because we all have a love of science and nature, that theme almost always ends up running in everything we create.
And Raven, what's your background?
I have a PhD in molecular biophysics and biochemistry from Yale, and I had always intended to be a scientist, but somewhere along the line got sidetracked. And now I consider myself a creative science communicator. So this project was right up my alley.
I also have to point out that you do made with molecules jewelry.
Yes, I do. Thank you. And since he's not here to represent himself, Martin brings a lot of tarot knowledge to the team. And we have greatly appreciated his background, where he's interested in psychology and stuff like that. And he's really added a lot to the mix.
I'd like to also add that Martin created the Peanuts Tarot before he worked with us on the Science Tarot. So he's not only a reader, but he's a creator and a published writer and filmmaker. So he has an extensive background in storytelling, which was also so helpful in bringing the Science Tarot to fruition.
So now those are the co-creators. So who are the artists?
We can work our way through the suits by working our way through the artists who helped us with the suits. Juan's suit was created by Janelle Schneider, who's a mixed media fine artist and a 3D texture paint artist, mostly for feature film, but she also does mixed media in acrylics. Pentacle's suit was Christy Whitehouse, who we met through the science illustration program, and she's also a practicing scientist. She's a chemist and geologist with the BS in cellular biology and a master's in science illustration. So she was truly a science artist. For the sword suit, we have Sherry Ari DeBoer, who is primarily a printmaker and also a painter with a background in architecture. And since she does etchings, was perfectly suited to the sword suit, where you are going to scrape onto a piece of metal and then print out your work afterwards. for the cup suit is Tammy Stolanova, and she has an extensive background in biology. She does a lot of work with marine mammals and is also a science illustrator. You can find her work at tammystolanova.com. She does jewelry of the natural world and creatures within it that you can find in many natural life museums. Our major arcana artist was the last person we found on the team, and that's Christian Johnson Michiels, who's also a printmaker and a watercolorist who's been working her whole life in that format and deals a lot in telling myth and story through her artwork. We had 2 tangential artists on this project. One was Suzanne Forbes, who painted the original Burning Man cards that we used on the Playa installation back in 2003, and which the current major arcana are based upon that Christian worked off of. And the other person is John Daniel, who created all the graphics for the deck, including the icon that we just absolutely adore and seems to turn everybody's heads even more than the word Science Tarot.
This was a truly collaborative project.
Yes.
When we got together to do this project, we didn't say, okay, you do this and you do that. We all kind of have our fingers in everything. And we've been so lucky to have such amazing people to work with.
So quite a few of you are actually scientists or have scientific backgrounds.
Yes.
So this is not as if you're using the word quantum to make your cards seem more sciencey. Your tarot is about real science.
Yeah, that was extremely important to us. A lot of these scientific terms get tossed around, but it was very important that our deck have real, accurate science in it. And both the creators and the artists did a lot of research and talking to people to make sure that that was the case.
Well, so I know I made the hippie joke before, but so are these cards designed to attract tarot users to science or science lovers to art or just to broaden people's perceptions of how we can communicate science?
Yeah, I think all of the above. You know, one of our audiences is tarot users who might not know that they like science, and when they use this deck, they will discover things that are interesting. And another group is scientists who may not feel an attraction towards tarot. We believe that tarot doesn't tell the future, but it can be a really interesting tool for meditating on your life and, you know, your own personal narrative in life. Our subconscious probably does know more than our consciousness does. It's better at putting together patterns. So it's just a way for our brains to think outside the box.
When you first look at the word Science Tarot, you think, okay, we're aiming for 2 different demographics, scientists and tarot enthusiasts. And originally that wasn't the case at all. We came to this project because, we wanted to create a tarot deck, we wanted to use science concepts because that's what we love. And it ended up being so much fun that we just went through the entire tarot deck, working with Raven and Martin and talking through the science concepts and deciding what stories would work where in the tarot was just fascinating. And we did it for a couple of years. The discussions we had were invigorating. And I think it's because we had this joy of the process that it's become infused in the deck. And then when we talk to people about the deck, they find that same joy in finding science stories that relate to their life in a visceral way that you really don't find many other places right now. And in that way, it's reaching out not just to an either-or demographic, but it's just finding the joyful inner scientist in anyone, whether they have a little love of tarot, a big love of tarot, an understanding of science, or they don't think of themselves as a scientist. It sort of cuts through all of that nonsense, and it's not either-or. It's, oh, hey, we're all in this world. We all experience the world through science stories, whether we're a scientist or not.
So would you say that art is definitely one of the ways that we can get people more interested in science as a whole?
I think people are already interested in science. I think that there's a communication gap between people who study science solely and people who simply live in a world of science. Here's a great example is, so we have a Facebook page and we've been posting a card about every week or so and giving the description of the card and letting people discuss the science story on the card. And one woman was very taken with the sun card, which shows the dual nature of light. It shows the sun behaving as both a particle and a wave. And she was so inspired by this that for her summer solstice ritual with her friends, they were going to build sandcastles on the beach and then have the waves come and wash those sandcastles away. Part of the ritual for solstice of doing this sort of a ritual is to wash away and to have a new beginning. And it's a time of renewal. And her take on this new ritual that they had created was that the sand was particle and that the waves were waves, and there's this behavior and interchange between the two. And now they have a new context for seeing light that is coming from the sun and to celebrate the sun's light. And their new story for that involves light behaving as wave and particles. So they're not coming at it from a mathematical understanding, and they're not coming at it from a scientific method understanding, but they don't need to. It's more that now they can describe their world with a story about the sun that is more true to the nature of the sun. So that nature was discovered perhaps by scientists and academia, but the story needed to be told in such a way that people who aren't academic-minded could then also understand it. There's no reason that all these people can't understand the world in the same format. It's just that the information isn't getting over to everybody else in a storytelling fashion.
And where can people find the cards?
We have a website called sciencetarot.com. You can find information about the cards as well as a page to order the cards if you so choose. We also have a Facebook page where people can post ideas about the cards and discuss the concepts behind them.
Thanks very much for being here, both of you.
Thank you so much.
Yes, thank you very much.
And now, to a bit of topical news. I'm here with Richard Murray, the lead organizer of the upcoming inaugural Toronto Skepticamp. Welcome to Skeptically Speaking, Richard.
Thanks, Desiree.
So one of the things that many people may not realize about skepticism is that it isn't actually full of scientists.
I'd hazard a guess that it's mostly full of non-scientists, amateur scientists, hobbyists.
What kind of range do we have then? What kind of people?
With the upcoming Skepticamp that we have here in Toronto, the volunteers that we've had that have come forward to give speeches on both on their own areas of expertise and areas that they're interested in. We have a lawyer discussing his specialty of libel law. We've got health professionals talking about naturopathy, homeopathy, how they may or may not work. Another speaker talking about the philosophy of science and pseudoscience and why people may choose to believe these things. Scientists don't necessarily know how to talk to people, other than your Brian Cox and your Ben Goldacres in Britain, or the late Carl Sagan, Phil Plait perhaps, who are able to address the public in words that the public can understand, and approach the ideas that the public has without being dismissive. The idea is to bring people in who are not necessarily skeptics. Events like the Amazing Meeting, where a couple thousand skeptics get together for a week that we can't talk about because it happens in Vegas, or Dragon Con, where we get together in the midst of a lot of geeks. Those aren't places where the amateurs really can come out. They already feel intimidated. There's a cost of entry there that is a bit much. Whereas here, a local person can come by, drop in for an afternoon, and there's nothing to be lost. They're not going to lose any money. They're not going to lose any face. And it's in a non-confrontational environment. It'd be terrifying.
So is there anyone in particular that you would really encourage to come to Skepticamp then?
Anybody who has ever had to make a choice between two things they didn't know anything about. Like cars. For me, buying a car, I don't know anything about those things. Having to make those choices and having to study and figure out what I want out of something, be it a consumer product, a health product, a political party to a degree, this kind of thinking can come into play. I'd encourage anybody to go.
So what I find interesting about the skeptical community is that we see more and more artists coming into the community. Now, I'm wondering, is the Skepticamp model something that attracts specifically those kind of people, do you think?
I'm not sure if it attracts specifically the more fine arts type of people, It doesn't scare them away. It's approachable, yeah. Like, none of the talks that we have in Toronto are really hard science. They're mostly focusing on society, politics, policy, activism. So it is really about critical thinking, and it's not so much about science, but it lends itself to science.
So where and when, sir?
We're actually running our event on a Saturday, a full Saturday, October 23rd, in downtown Toronto, just off the university. We have a lovely room donated by the Centre for Inquiry here in Toronto. And there's a very nice pub right around the corner for afterwards.
So there's a number of cities that are actually holding Skepticamps the same day as you.
Yes, from west to east, I guess. We've got Vancouver, Winnipeg, Toronto, and Ottawa, who are all holding similar events on the 23rd of October.
So there's something important about the 23rd of October.
The date 1023 for October 23rd, it refers to the Avogadro constant. It's an offhanded reference towards the dilution factor of homeopathic products and how many atoms can possibly be in solution in a homeopathic product. It was used mostly as a demonstration against the efficacy of homeopathy. At this point, the October 23rd is mostly a coincidence.
So if people want to find more information about the Toronto Skepticamp, or really any Skepticamp that's happening on October 23rd, where should they go?
All the upcoming Skepticamps have a link off the main Skepticamp wiki page. If you just go to skepticamp.org, it's with one C in the middle, all of the upcoming events from this weekend's event in Washington, D.C. on down to New York in December are listed there.
Good luck, guys.
Hey, cool, we finally broke 30 people. Ooh, and he's volunteered to bring snacks and or a parrot.
That's brilliant. I like that.
Thank you, Desiree.
And we'll be right back with more Skeptically Speaking after this.
Skeptically Speaking wants you to question everything. You can email your questions for next week's episode to live@skepticallyspeaking.com, or if you're on Twitter, we're at Skeptical Radio, or use our handy question submission box on the website at skepticallyspeaking.com. You can also subscribe to the show in iTunes or listen to past episodes, and while you're there, why not add your review? Skeptically Speaking is rebroadcast on a number of fine radio stations. Check the media page at skepticallyspeaking.com to see if we air near you. And now, back to the show.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell. I'm here with Daniel Levitin, neuroscientist and director of the Laboratory for Music Perception and Expertise in the Department of Psychology at McGill University. He's also the author of This Is Your Brain on Music. Welcome to the show, Daniel.
Morning, Desiree. Oh, no, it's not morning.
No, it is.
Evening, Desiree.
This is a pre-produced program, folks. We've had some time zone-related issues. They are the bane of my existence.
Oh, but let them think it's live.
No, because otherwise we get people calling in.
I know, wouldn't that be fun?
I believe there was a Mr. Show episode on that. Well, let's start with the basics. Maybe just give us a quick overview of what actually happens in the ear when we hear a sound.
Well, it's actually quite remarkable, Desiree, because we have the sense, we have the impression that, in effect, we're just hearing what's going on in the world, and that there isn't any magic to it or any mystery. But what's really going on is that your eardrum is vibrating in and out in response to molecules in the air that are disturbed by sound. And your eardrum wiggling in and out begins a chain of electromechanical events that causes your brain to analyze that wiggling in and out and turn it into sounds like thunder or a cat purring or the oboe in the orchestra.
So it's really a mechanical process then. The movement of the air is physically changing a part of your anatomy.
It's changing your eardrum, the tympanic membrane, and that it changes it in particular ways that through tens of thousands of years of evolution, our brain has figured out how to interpret that wiggling as sound, and not just sound, but as very particular sounds. We can distinguish an oboe from a guitar, from the fan in the concert hall, or from somebody coughing. But the origin of all those different sounds is simply the wiggling in and out of the eardrum.
So you point out in the book that much of what we think of as sound is really an internal process that happens in the brain.
So it's all in the brain. And it's so much so that I look at it this way. If you didn't have a brain to intercept the vibrating molecules, it wouldn't really be sound. It would just be disturbances in the atmosphere. And so, the answer to Bishop Berkeley's question, the famous one we all learned as students, if a tree falls in the forest and no one's there to hear it, does it make a sound? From a cognitive neuroscience standpoint, no, it doesn't. It disturbs the atmosphere. It disturbs the molecules. But sound is something that is constructed in the brain of some sentient organism, a human, a marmoset, a dog, even an insect, but with their tiny little brains. But, sound is not something that's there if there's not a brain there to perceive it.
So really what happens next depends on what sounds we're hearing then.
Right. So the brain has to construct this reality of sound, again, from this wiggling, and it processes sound in components. We don't realize it, but as soon as the signal hits the brain sends it out to some specialized neural circuits. So some of these circuits figure out how loud the sound is. Different ones figure out where it's coming from. And different neural circuits from that figure out how long it lasted, what its tonal color was, say what which distinguishes a trumpet from a piano. They figure out its pitch, and then it all comes together later as a complete whole object. And you go, oh, that was the opening note of Satisfaction by the Stones. But later in brain times is maybe 40,000ths of a second later. It happens so fast you don't realize that all these components are being built up and put together.
And the reaction of our brains to music differs from its reaction to speech then.
Yeah, and that's an interesting story. It seems as though there are dedicated circuits in the brain, dedicated networks of neurons, that are selectively tuned to speech and others that are selectively tuned to music.
But this isn't as simple as left brain, right brain.
No, we used to think so. You might have learned that if you were a student 20 or 30 years ago, as I learned it. But it turns out the story is a lot more nuanced and a lot more interesting. Both halves of the brain contribute to our understanding of speech and to music.
Well, what distinct parts of the brain are affected?
Nearly every region of the brain is affected by music, nearly every region that we know about. The obvious ones, just above your ears, maybe by coincidence, but anyway, conveniently, just above your ears is the region of the brain called the temporal lobe, and a portion of the temporal lobe we call auditory cortex, because that's the part that handles sound. Now, it's not always that way. The part that handles smell isn't just above or behind your nose, and the part that handles vision isn't anywhere near your eyes. But it works out this way with hearing. And after auditory cortex, some other areas that are involved are the frontal lobes, the parts right above your eyebrows. They're involved in trying to predict what's going to come next in either speech or music. And they're pretty good at it. So if I were to start a sentence like this, the pizza was too hot to sleep, the part of you that's surprised with what I said is the frontal lobes, because they were expecting something different than that.
Well, I'm particularly interested in the mesolimbic system, I have to say. How is that affected by music?
Well, the limbic system is part of a network of structures that have been with our animal cousins for many hundreds of thousands of years. So we call the limbic system the reptilian brain sometimes because even reptiles have a rudimentary limbic system. That's how far back it goes phylogenetically. So it includes structures like the amygdala, which are responsible for fear and for emotional reactions to things. If you hear scary music, like Bernard Herrmann's score to Psycho, the violins in the shower scene, that's the amygdala that's giving you the sweaty palms or the hair standing on end. And what we've learned in the last few years is that the amygdala and other portions of the limbic system have direct connections to sound. And one of the reasons we think that people have such strong emotional reactions to music are these connections to the mesolimbic system. It's also interesting to note that it's not just fear that's mediated by these regions, but pleasure. This is well known by the Canadian psychologists James Olds and Peter Milner. It's been long known and well known as a pleasure center. This is the part of the brain that if you put a rat in a cage and you allow it to press a bar that will stimulate its limbic system, the rat will do that and do nothing else. It won't eat, it won't sleep, it won't mate. It'll just keep stimulating that pleasure center.
Does this have something to do with like serotonin and dopamine and such?
It does. So serotonin and dopamine are two chemicals that are naturally occurring in the brain, and the brain releases them. It sends them around where needed. They're associated with the emotions and the feelings of being in a positive mood, being happy, content, and being able to focus your concentration. Now, of course, it's more subtle than that, and they interact with each other and with other chemicals. But because they're associated with mood, we now have a whole class of drugs called serotonin reuptake inhibitors, SSRIs. That's Zoloft and Paxil and Prozac and the others. And it turns out that music is able to mediate the dopamine part of the system, maybe serotonin, we haven't seen that yet. But when people listen to music they like, the brain produces a squirt of dopamine, which is the same chemical that's produced when you eat chocolate, provided you like chocolate, or if you are a gambler and you win a bet, or you're a cocaine addict and you get some cocaine, or if you have a sexual experience, dopamine is being produced in all those cases, and in music.
So basically, the emotional experience of listening to music actually does get you high.
It does. I mean, I guess it depends on what you want to call high, but it alters the chemistry of your brain. So you could say that music is like a drug, I suppose.
Well, another system that reacts particularly...
Cue the Huey Lewis song.
I know. I was trying so hard. Well, another system that reacts...
we can't play that, can we? Because we'd have to pay licensing.
We would have to pay licensing. You understand this, sir?
It would be expensive. It might cost your radio station $1,000 to play 10 seconds of that song, I'm imagining.
And are you aware of how much money community radio stations have?
I think I am right now.
So the other system that responds to particularly songs that we like is the cerebellum.
Yeah, now that's an interesting story. The cerebellum is a structure that, again, is common to all vertebrates. For a long, long time, we thought it just had to do with movement. So it was more like, it didn't respond to the song Start Me Up, but just to continue the Stones theme, but it was the thing that started you up. It's the thing, the cerebellum was responsible for moving, for allowing you to plan and coordinate moving your legs, to go out and seek food and shelter and mating opportunities, to put it nicely. And we find in patients with Parkinson's disease, which is a deterioration of the cerebellum, one of the symptoms is they're unable to walk or they're unable to move with smooth, continuous motion. The surprise with the cerebellum to scientists has been that it's not only related to emotion, but it's particularly related to musical emotion. And I think this is part of the key to understanding how music works its magic. Do you believe in magic? Love and Spoonful. Another cue. I think it's because music has rhythm. It has this pulse. And pulses like that stimulate the cerebellum directly, because the cerebellum, again, is responsible for movement, coordinated movement. That's the part of you that would have you all rowing in synchrony if you were in a rowboat, or would have you running together or marching together if you were with other people. Things that were very important for our ancestors on the hunt, right? You had to move in synchrony in order to bring down some big beast. So this idea of synchronization of your movements has a very ancient evolutionary origin. The pulse of music seems to stimulate these rhythmic portions of the cerebellum, and that's one of the reasons we want to dance to it, and one of the reasons we have this emotional reaction, because the cerebellum is in turn involved in mediating emotions and motivation.
So you mentioned that the brain anticipates what the next beat will be. So is this the part of the brain that does that then?
It's not. This is not as far as we know. I have to qualify all these things because brain science is still relatively young. Mm-hmm. But it seems as though the cerebellum is able to keep track of I suppose you could say it anticipates when the next beat will be. The real job of the cerebellum is to set up a kind of a clock that synchronizes with things. And so, of course, it has to predict what's going to come next. But the part that's most acutely aware of any violation of an expectation is in that prefrontal cortex we talked about earlier, just behind your eyebrows. That's the part that's surprised when you say the pizza was too hot to sleep, or is surprised if I play you a musical sequence that doesn't make sense. If you allow me, I'll demonstrate here.
I'm so excited.
So it would be a particularly normal chord progression if I were to play something like this. But that's not normal, right?
Right.
And your brain knew that. You don't know the names of the notes probably unless you have absolute pitch. And you may not even know the names of the chords. But when you hear... something sounds a little off. And it's a violation of your sense of what the norms are in Western music. You don't have to know music theory, but your brain is a giant prediction device, and it's spent its whole life, as it were, trying to figure out regularities in the world.
So you say in the book that our brains actually take satisfaction in being able to predict that.
Ooh, another Rolling Stones cue. We're going to have to give them some money anyway, just for the song names now. You're suppressing laughter.
I'm trying.
I think it's okay to laugh on public radio.
I think it is. I think it is.
Yeah.
Well, so go ahead.
Yes, the brain does get a sense of satisfaction. You could think of it as kind of like a sweet satisfaction, almost like brown sugar. And the satisfaction is because we evolved in a world where it would have been adaptive for us to learn new things about the world, where there's a new well, where we can find a new fruit tree. And so the way that the brain encourages us to do things is that it releases dopamine and gives us a feeling of pleasure, satisfaction. We like learning new things because it's adaptive for us to do so. The brain rewards us by getting that hit of, oh, that's cool. I'm glad I learned that. And we're doing this subconsciously thousands of times a day. And as children, we're hearing speech and we're hearing music. And we learn the regularities of musical forms. As children, any 4-year-old can tell you that sequence I played sounded funny.
You also say, though, that the brain enjoys violations of those expectations.
Right. The reason is that if the violation is done artfully, in a way that makes sense, it's teaching us something new about the world that also makes sense. I think the metaphor is, I may know one route to the well, but if a friend of mine shows me there's another way to get there, I'm kind of tickled by that. And it's useful for me to know an alternate route to the water well in case a tree falls or there's an avalanche or there's a neighboring tribe blocking the access or something, right? And so if we think of music as being a route, a way to get from one chord to another, or to get from the beginning of a sequence to the end of a sequence, anything a composer can do to show us there's another way to get there is interesting. There's a famous trick that McCartney uses in his songwriting that he didn't invent, but he sort of popularized as a new way to complete a musical phrase. So just to continue with chords I was playing earlier. That's a normal kind of a sequence in popular music, right? McCartney does this. And he's done that a lot of times. We're not used to hearing that. That third chord I played is actually not in the key, but it works. And we like it because your brain is learning, there's not only a different way you can get there, with there being the final resolution, but it's an interesting way that you wouldn't have predicted and wouldn't have thought of. And so that's taught you something about the world that you didn't know.
You're listening to Skeptically Speaking.
Your name isn't Angie, is it?
No. I love your references, sir. Okay. We're talking today with Daniel Levitin, author of This Is Your Brain on Music.
I want to be your man. Let me not fade away. We better hurry because pretty soon it's going to be all over now.
Oh, man.
But, on the other hand, time is on my side.
Yes. Oh my. Well done. So to figure out the brain's role in enjoying music, you used something called the functional and effective connectivity analysis. Can you explain how that works?
Yes. Imagine that as the blood flows through the brain, it goes to the places where it's needed most. This is the assumption on which a lot of our current technology is based. When you see these colorful pictures of the brain in newspapers and magazines, effectively the technology was we have a machine that looks at where the blood goes in the brain. That's an oversimplification, but if you want to paint it black, that's the simple way to look at it. So that was another Rolling Stones reference.
Yes. I was, again, trying not to laugh.
We can see where the blood is going, and with this functional connectivity analysis and some fancy mathematics, we can figure out what the cascade of activity is. That is, in what order different brain regions become activated in response to something. Now, that something could be a person looking at pictures or solving equations. In our experiments, it's usually a person listening to music. And the time course of activation of the brain activity can tell us a lot about what the brain is doing and how it's doing it. And it's through this fancy mouthful that you said that we were able to determine that dopamine was being released in the brain in response to people listening to music. Now, your listeners might say, well, I don't understand. Why don't you just measure the dopamine? Why all this fancy talk? Well, the problem is you can't measure dopamine directly. It doesn't cross the blood-brain barrier, so I can't just take a blood draw prick your finger or something like that, take it out of your arm and read it there. And I can't really get into the blood in your brain without putting a needle in there, and that's uncomfortable. And so wild horses couldn't get me to do that. So the idea is that we have to make some inferences, and we can do that based on some regularities of the brain. The neurons that are doing a lot of work need oxygen in order to metabolize their processes. Their living cells need the oxygen to function. The harder they work, the more oxygen they need, mainly, most of the time. And so we use this scanning to see which neurons are firing when and in what order.
So I have to ask, do different genres of music cause a different order of that cascade?
Yes, they can. I think in the cases that we've looked at, and again, this is all still at the beginning, it's not that the different genres of music cause a different order, but they do activate different parts of the brain. So James Brown is more likely to activate the cerebellum that we were talking about earlier, the timing and rhythm center, than Vivaldi is. And music with lyrics is more likely to activate those parts of the left hemisphere that translate speech into something meaningful, as opposed to instrumental music, which is more likely to activate the right hemisphere.
So does the complexity of music have something to do with that then?
All this echo isn't giving you your 19th nervous breakdown, I hope.
You could literally do this all day, couldn't you? Oh, okay. Yes.
Try a little harder.
Okay. So does part of this have to do with the music's complexity then, or is it more just dependent on the music that the individual enjoys?
It's the latter. James Brown is going to activate the pleasure center only if you like James Brown. And, Vivaldi's only going to do it if you like Vivaldi. And musical tastes are so individual and so idiosyncratic, we can't really make any hard and fast rules about what the average listener is going to have happening in their brain in response to a particular piece of music. But as I was saying, there are some sort of general rules. So the more rhythmic you find the music, as opposed to the more rhythmic the music is, the more the cerebellum's going to be activated, and the more interested you are in the lyrics, the more the analytical parts of your brain and lexical parts of your brain are going to become involved.
Do we know why certain kinds of music are attractive to certain kinds of people?
We know a little bit about it. Let's spend the night together and maybe we can understand it. continuing with the Rolling Stones theme. The idea is that beginning in the womb, the fetus is already able to hear some of the auditory environment by 20 weeks through the amniotic fluid. And at birth, infants show a preference for the music that they heard in the womb. This is because their brains are already starting to figure out certain regularities. They notice things that are familiar. And to some degree, our musical tastes are a function of the music that we were exposed to from a very, very young age. Now, that's not entirely the story, but it's unlikely that the average Canadian is going to become a huge fan of Chinese opera or Indian ragas if they were listening basically to Western tonal music. And the reverse is true. It would be the height of arrogance to think that Western music is better. You know, when we launched the Voyager probe some 30 years ago and sent it off into space, we sent it with some depictions. There was a map of where we were in the solar system, and they sent, I think, a picture of the human body, and they wanted to send up music. They did actually send some music. They wanted to send music so that any aliens that encountered it would be able to hear some artistic objects. But in retrospect, it was kind of a silly idea because, you know, just imagine that you played Bach or one of, you know, the most sophisticated pieces of music we know to somebody that doesn't have that tonal system as part of their culture. The Chinese, for example, or the Indians from India. Bach isn't going to be particularly beautiful to them. And I remember there was a scientist who there were a number of scientists, you know, arguing about what music to send. And one of the scientists said, well, we could send Bach to the aliens, but that would just be boasting. You know, it's a funny remark. Yeah, Bach is lovely and he's wonderful, but only if you like him. And only if you understand it. And that understanding is largely cultural. There's nothing in music that requires that Bach should have existed, or that the notes that we use be the ones that we use.
Well, on a related note, we have a question from the website.
Oh, cool.
I've always wondered why certain chords tend to seem happy and other chords seem sad. And that's from John.
Well, this is largely cultural. And in our culture, major chords are considered happy, and minor chords are considered sad. But part of it is because, as I just did, they co-vary with tempo and feeling. So we tend to play the major chords as kind of bouncy, and the minor chords slower and less bouncy. But there's nothing that says we have to do it that way, and there's nothing intrinsically about them that makes them happy or sad. In fact, if you listen to klezmer music or a lot of Middle Eastern music, it's mostly in minor keys, and it isn't all sad. I can play a minor chord fast. And it might sound thoughtful, but it doesn't sound sad necessarily. But to the extent that it does, it's cultural. We've learned the association because composers in our idiom for generations, for hundreds of years, have reinforced this notion that major is happy and minor is sad. But you play these for people in the villages of China who've been cut off from Western music, they don't identify them with happy and sad.
Well, you mentioned scary music before. Are there scary chords?
I suppose there could be scary chord progressions. Well, again, a lot of that's cultural. We tend to think of things that are dissonant as being scary, but what's dissonant to some of us isn't dissonant to others. Again, it's cultural. I suppose I can't play anything scary on the guitar. I don't know how to do that. But
you can't play the psycho music on the guitar?
Sorry, I don't have my bow. It's a sad day.
Well, I'm wondering because music seems to be used as such a primer.
You can't always get what you want.
Oh, God. That one hurt. I'm thinking because, you know, certain music is used as almost a primer for certain emotions.
Well, of course it is. I think that, in fact, that's why we have music. I mean, for some of us who spend our lives practicing scales and trying to do, you know, things like this without making mistakes, the technique is everything. But for most of us and for most listeners, it's not about technique. It's about the emotions. we have music in our lives because I think throughout tens of thousands of years of evolution, music turned out to be a better way of communicating emotion than anything else we had. Better than speech, better than facial expressions. It can be certainly far more nuanced than speech. Think about a time when you were feeling crummy and you didn't know quite how to explain to yourself or to others what or how you were feeling. But then the right piece of music comes on and you go, yeah, that's it. That's how I feel. And so, yeah, music underpins our emotions and it evokes emotions because that's why we have it. That's what it's there for.
Well, you talk about the music that you heard in your teenage years really being the best music of all, and that there's neurological reasons for that.
Well, the music I heard in my teenage years is the best because it really was. But in the general case, all of us think that. And part of the story is hormonal, and part of it is social psychological. How much time do we have?
You just keep talking, sir.
Well, is this a half-hour interview or is it an hour?
It was supposed to be a 45. And,
we've still got 4 minutes then.
Yes, we're fine.
I'm not off the hook.
No.
That was from the Rolling Stones.
Yes. I'm quite aware of their catalog, sir.
Oh, are you? Congratulations. So part of the story is hormonal. When we hit the pubertal growth hormones, they tend to make everything seem really important. And so it's not just the music of our early teen years that we remember. We remember our friends. We remember movies from then, books. And the way memory works is that in general, we tend to remember the things that have the most emotional meaning to us. And all kinds of stuff from our early teen years is infused with meaning, largely because of the hormones. And so we remember and like best the music, as a rule, from the ages of 12 to 16. That doesn't mean we'd stop liking music after then, but to some degree our tastes are formed then. As 40-year-olds, we don't really want to hear the music we heard when we were 15 all the time, but we want to hear music that has some of those qualities or some of those properties. But it's not just hormonal. Part of it is social. During that age, we're discovering for the first time that we don't have to be just like our parents were. We can really engage in a bit of self-invention. We can have our own tastes. We can like what we want to like. And we do this through social alliances. We dress the way our friends dress. We listen to the music they listen to. And certainly in schools all across the nation, there are groups of kids saying, we would never listen to the music that those kids listen to. This is our music, that's their music. Or we'd never dress like they do and we don't talk like they do. So there's this sense of social identity that's emerging. And out of that comes a sense of preference.
We have another question from the website. Can one improve mental capacities, for example, memory and cognition, by learning to play a new instrument? Have there been any studies along this line?
Learning to play an instrument can help to exercise the brain at any age, and can be a very effective way of keeping eye-hand coordination. Any instrument other than voice that require, most instruments require you moving your fingers in some way. You're training fine motor control, motor coordination. With singing, you're still you're helping to exercise muscles. The vocal cords are muscles, and you're learning fine motor control there as well. And it's engaging the brain in new forms of thought and new patterns, and that helps as you get older. Not only gives you something to do, but it keeps the brain young and active and may actually fend off Alzheimer's. We were talking earlier about the space probe. Remember the Voyager they wanted to send up Bach? I forgot to mention that they were sending it 2,000 light years from home.
Oh, my God. I can't believe you missed that one.
I know, I'm sorry. I'm shattered.
Oh, God. I'm going to need, rehab after this or something.
You want to get to Amy Winehouse.
Okay,
I'm going to be more challenging.
I'm going to put this part in.
Of course you are. It's all in.
Oh, God.
Surprise.
Oh. You're listening to Skeptically Speaking, and we'll be right back with more of Daniel Levitin, and this is Your Brain on Music after this.
On the next episode of Skeptically Speaking, it's an hour on science journalism. We'll speak to Boris Zivkovic, blog and community editor at Scientific American, about how online science reporting and the explosion of science blogging are affecting the way science news is brought to the public. And on Speaking Up, science journalist Stephen Strauss will tell us how the decline of the newspaper industry has affected his profession. That's next week on Skeptically Speaking, Friday night at 6 Mountain Time, live at skepticallyspeaking.com.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell, and I'm here with neuroscientist and author Daniel Levitin. He's written the book, This Is Your Brain on Music. I do want to point out that what we didn't discuss in the interview is sort of the more autobiographical portions of this book, because you're a musician as well, obviously.
Well, that's generous of you to say. Is there a question in there?
It's coming.
Hey, I'm waiting.
There are literally tons of stories in the book about your experiences. But what would you say has been your favorite moment as a neuroscientist musician?
This one right now, Desiree.
Oh, you're a beautiful man.
This one right now.
Well, how about the second most amazing?
Well, I think probably one of the most amazing moments was when, after my book came out, after This Is Your Brain on Music came out, I got a call from somebody I didn't know who represented Sting, the musician Sting. His people called me. If I had people, his people would have called my people, but I don't have people. So his people called me, and they said, Sting's coming to Montreal with the police, and he read your book, and he wants to meet you. And I just thought that was the coolest thing. And when we met, he decided that he wanted to have a brain scan. He wanted to know what his brain looked like. And so we did that, and as some of your listeners may know, we made a film out of that called My Musical Brain, which was shown on CTV, and I think they replay it every few months. But that was really thrilling. It was thrilling to meet somebody that had been a musical hero of mine, and not just a musical hero, but a kind of, I think, artistic hero. I admired and respected Sting for not being complacent and for, he could have just stayed with the police and done police stuff for the rest of his career, but he was restless and active as an artist and wanted to explore other forms. And some of them were commercially successful and some weren't. But to me, I saw parallels in what we do in science. Sometimes an experiment works and sometimes it doesn't. Sometimes a lot of people hear about it and read about it, and sometimes they don't. But I think, if you're of a certain kind of personality, you're trying to satisfy your curiosity, and you're looking for things in places that people haven't looked before. And that's one of the things I think that art and science have in common. And it was interesting to be able to talk with a great artist about how he does what he does and to compare notes.
Audience, that is our time. I recommend highly you pick up this book. Thanks very much for being here, Daniel.
Thank you, Desiree.
You can find Daniel Levitin at yourbrainonmusic.com. And we are, as always, at skepticallyspeaking.com. Click the links to Twitter, to Facebook, to our past episodes, and to iTunes, where you can subscribe to the show. Thanks for listening, and we'll see you next week on Skeptically Speaking.
I think you should call this episode Dancing with Mr. D.
Oh, that was awesome.
Stop breaking down.
Bring it on. The skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Schell gonna raise a little hell, break the spell of Pavlov's spells. Cause we're skeptically speaking on mind reading, tarot cards and witches, psychics, and their spoon-bending mind tricks. All the humbug, flim-flam, frauds and shams, the charlatan who I don't think you understand. It's the hocus pocus, out of focus locus, eroding the brain, making gains on the hopeless. Let the crystal ball fall, smash on the floor, leave the pieces alone. We don't need them anymore. Just a microscope, telescope, magnifier, reading in between the lines of these lies. Bring it on. The skeptics await your letter. Your Desiree Shell gonna raise a little hell, metaphorically that is, 'cause we're skeptically speaking.